Hello everybody and welcome to part 15 of our little beginner series here. In this part, we're going to be focusing our attention on render settings. So we're going to show you how you can take your renders from looking like this to looking like this. Now, fortunately for us, with these newer versions of V-Ray, render settings have become really streamlined, and so there's really not a whole lot to worry about or to tinker with, really, if you don't want to. That said, it's always a good idea to have some sort of a basic understanding of some of the most basic render settings, and so that's exactly what the focus of this video will be. All right, so the first thing that we're going to cover here is going to be the render engine choice that you have. Now, this is a parameter that you should tweak before you start working on your actual project. That is because V-Ray basically comes with two different render engines. One of them is the V-Ray render engine, and the other one is the V-Ray GPU render engine. Now, both of these will produce very similar results, visually speaking, but their feature set is going to be a little bit different, and the way that they, well, basically calculate the image is going to be a little bit different. And so by and large, with the render engine parameter, you should have it set to the option that you started off with when you started, well, working on your actual project. All right, but then when do you go with V-Ray and when do you go with V-Ray GPU? Well, first of all, if you have a very powerful CPU in your system, well, then you might want to go with V-Ray. If you have a very powerful graphics card in your system, or multiple of those, well, then you might consider going with the V-Ray GPU renderer. There are feature differences between the two. We're going to link to the document where you can see what some of those differences are. It's going to be down in the description of this video. But by and large, you should really treat these two render engines as separate render engines. Yes, the UI is going to be very similar. There's going to be some changes here and there. And yes, the output, the final rendered image, it's going to be quite similar. But at the same time, these are very completely different render engines. They are being ran by different algorithms and so on and so forth. So really, the most important thing for you here is that the render engine that you pick at the start of your project, that's the one you want to stick with, okay? That's the most important thing for you to know as a beginner. All right, so next up, we're going to talk about the image sampler. So the sampler type is where you choose what kind of an image sampler you want to use. You have two options. You can choose between the progressive mode and the bucket mode, or type, really. And now let's first take a look at the progressive mode. If I start up the renderer right now, so I'm just going to start up the final render, okay? And we're going to give V-Ray a second or two just to start up here to compile the geometry and do all that magic. All right, but before you know it, as you can see, we're going to be up and running here. Let's just give it another second. There we go. And now if you take a look at how this image is being rendered, you're going to be able to notice, let's just disable the denoiser here. Okay, just like that. If we take a look at how the image is being rendered, you're going to very quickly be able to notice that it's being sort of progressively refined over time. Okay, so the more time that passes, the more the image sort of gets noise free, right? Now, that is basically the essence of how the progressive sampler type here works. It will progressively refine the image until you sort of reach the one of the end parameters that you can set in the render settings right here. And the most common parameter that's going to end the rendering process for you here is going to be the noise limit parameter. Okay, so by default it's set to 0.01, and it's a pretty good value that's going to work pretty well for most of the scenes, but this parameter is very scene dependent. So depending on what kind of materials you have in here and what kind of lighting you're dealing with, you might want to maybe up the noise limit to 0.08, or you might actually want to lower it to maybe 0.003 even. Okay. Now, what this noise limit parameter basically does is it basically, it tells V-Ray when to stop rendering, but the way that it works is it takes a look at the image and it kind of calculates the noise in the image. Okay, and so basically you're defining the threshold at which we're kind of happy with the noise that we have in our image, and at that point we're saying, hey, this render is done rendering. Now, if you want to take a look at, at how much noise is there in your currently rendered image, just go under the stats menu here and go under the noise threshold sort of a readout here. And as you can see right now, our noise threshold is at 0.043. Okay, and this entire image that we're currently rendering, as you can see, that value updated a little bit because we've completed a couple of additional progressive passes here. So the image refined a little bit as we were talking, right? And as you can see, the value just keeps getting lower and lower. All right. Now, when we reach the noise threshold of 0.01, the one that we've set here in our render settings, well, then that's when V-Ray is going to be like, oh, okay, this image is done rendering. All right. And now you can totally, sometimes you're going to be totally happy with more noise in your image. It's going to be perfectly fine. You're just going to enable that denoiser, right? And it's going to sort of eat that noise away, right? But at other times, such as, for example, in this current scene that we were rendering out now, right? You're going to very quickly be able to notice that, well, the denoiser is, well, it's just too aggressively denoising everything. And so we're just going to have to let this one render for a little bit longer. Otherwise, we're kind of losing the details with the denoiser. Okay. And so to have a really good idea of what noise threshold is going to work for you, just do a couple of test renders, see what value you end up with here, and then just, you know, input that noise limit in here as well. Now, additionally, you can also input the max render time in minutes here as well. So if you set it, for example, to 5, well, then after 5 minutes of rendering, okay, so right now I've been rendering for 3 minutes, right? After 5 minutes, V-Ray is going to be like, okay, this image is done rendering, and that's it. Now, if you have both of these parameters set, sort of like this, okay, it's going to be, V-Ray is going to be like, I'm either going to hit the noise limit of 0.01, or I'm going to hit the max render time in minutes. So either one of these conditions gets met, the image is going to be done rendering. Okay, and now it goes without saying, whenever you're making changes to these parameters here, you're going to have to stop the render and restart it. Okay. Now, when does the max render time in minutes parameter come in handy? Well, let's say, for example, you're rendering out an animation. That's a pretty typical use case. And let's say you're rendering out a preview. You know you're gonna be off work for 8 hours, let's say, right? And you want that preview to be done rendering in 8 hours. Well, then you can very easily do the math. You know how many frames you've got, and you know how much time you're gonna spend rendering out each frame, right? And so you can just input the max render time in minutes. And, you know, in 8 hours, for example, when you come back, right, you're going to have that animation rendered out. Now, it might still be a little noisy, but, you know, you're going to render it for the exact amount of time you specified. Now, there is one parameter here that we really haven't touched yet, but it's kind of worth mentioning what it does, even for a beginner, although as a beginner, you're really not expected to tweak it at all. Okay, but just so you know what it does, we're talking about the max subdivs parameter. And this parameter, basically, if you up it, well, then V-Ray is going to be able to throw more samples at a given pixel. That is a bit of a layman's explanation for what it does, but as a beginner, that's pretty much all you should know. You're not really expected to tweak it pretty much at all. All right, so that was the progressive sampler type, but then we also have the bucket sampler type. Now this one just has the simple noise limit parameter, and the main difference here is just going to be in how your image is being rendered. So we're rendering out an image right now. We've set the sampler type to bucket. Let's give V-Ray a second here to start up. And there we go, we're in action. So now, as you can see, we've got these buckets, these little squares here, and this is how the image is getting rendered now. All right, so V-Ray is basically going to split this image into buckets, and then it's going to render each bucket sort of individually. Okay, as you can see, once this noise limit is met in that bucket, basically, then that's the time where V-Ray is going to be like, okay, I'm done with this portion of the image. I'm moving to the next one. As you can see, these buckets are just going to continue moving on here. Okay, so that's how the bucket type works here. And the noise limit works exactly the same as it does for the progressive render. So nothing really different there. And the main thing is just that with the bucket progressive type, as you can see, well, with the bucket sampler type, not progressive type, with the bucket sampler type, as you can see, it's a little bit harder to get a good idea of how the image is looking, right? Because it's not progressively being refined, it's just being sort of rendered in these buckets here. Okay, but now why is the bucket sampler type even an option because the progressive one seems to be like the obvious choice, right? Well, with the bucket sampler type, you're getting a more memory optimized rendering of the image because V-Ray essentially just renders the image out in those little buckets and those little tiles, right? And so, for example, for holding in the VFB data, V-Ray just needs to focus on those little tiles. It doesn't need to focus on the entire image as a whole. And this can be really useful for whenever you're dealing with super high resolution images and things like that. Okay. Now, another thing to mention with the bucket sampler type is that it's a little bit more efficient when you're rendering with V-Ray. So when you're rendering on your CPU with the V-Ray render engine. If you're rendering on your GPU, so you're using the V-Ray GPU renderer, well, then the progressive sampler type might actually be a little bit more efficient. So there's that to consider as well. Now, one thing that you've also probably noticed at this point is that with the bucket sampler type, you also have that max subdivs parameter. And again, it does the same thing as it does for the progressive renderer. We're not going to go into the details of how it works and when you should tweak it, because by and large, as a beginner, you really shouldn't worry about that parameter at all, okay? All right, so next, let's take a look at the denoising options that we have available to us here. Now, we already talked about the denoisers in one of the earlier clips, so we're just going to do a bit of a quick recap here. Now, at the moment, we're using the NVIDIA AI denoiser. This is a denoiser that runs on your graphics card, on your NVIDIA graphics card. And by and large, it is a very fast denoiser, but maybe it's not quite as quality focused as some of the other options. And that's why the NVIDIA AI denoiser is most oftenly used for when you're doing interactive rendering, because it's really blazingly fast at denoising your image. Now, as an alternative, you can use the Intel Open Image Denoiser. That's another great option. And this one runs on your CPU. It doesn't have to be an Intel CPU. It can be an AMD CPU as well. And it's kind of like a balanced sort of thing that's kind of, it's focused on the performance, but it also is focused on the quality. So it's kind of like this in-between option, okay? You can use it for final renders, totally fine. Or, you can use it for interactive rendering. It's going to be totally fine for that, although probably does depend on your graphics card. The NVIDIA denoiser might be a little bit faster for the interactive render, but definitely do experiment. And as a third option, you have the default V-Ray denoiser, and this one is sort of the chaos developed denoiser, and it can run on your CPU and it can run on your GPU. It can be accelerated by your GPU, by your graphics card. And it has a couple of presets here that you can use. Default tends to work fine in most situations, in my opinion. And the idea here is that the V-Ray denoiser is mainly focused on the quality. Okay, so it might actually be the slowest out of the three, but in terms of how much detail it eats up, it might actually be, well, more quality focused because it's not going to eat up that much detail. Okay? Okay, all right, we're making good progress here. And the next thing that we're going to check out here is the V-Ray output system. All right, so the V-Ray output system can be accessed from the common submenu here, and you can just toggle it to on here. And now basically what's going to happen is the Cinema 4D sort of save functionality is just going to get ignored. Okay, and you're just going to use the built-in V-Ray output system. Why can this be useful to you? Well, as you're going to notice here, you have a couple of formats that you can save your images to that are otherwise unavailable to you if you go with the Cinema 4D sort of save functionality. So I'm talking about the V-Ray image format here, and the VRST image format, and so on and so forth. So you might have access to some of the formats here that you otherwise wouldn't have. And also one really neat thing here is if we go with a PNG format, if we just expand this rollout down here, you're going to be able to see that you can define the compression for that particular format. So for example, if we go with JPEG, you can also define the quality and such. So basically you just have some additional sort of parameters in here that can affect the sort of the image and how you're saving it. Okay. Now you don't have to use the V-Ray output system, especially as a beginner, but if compression is important to you or things like that, well, you might just you might want to toggle it on here and just play around with all the different options that the V-Ray output system gives you. Now, one thing that we should still talk about while we're in this V-Ray image output rollout here, one thing that we should still talk about is this apply VFB compositing and color corrections toggle. Now, by default, this toggle is going to be toggled on for you. And what it does is it basically, whenever you're saving out your image using the Cinema 4D's picture viewer, okay, so whenever you, for example, hit this render to picture viewer button, or whenever you're saving out your images sort of like this, when you enable the save functionality in here, and then you specify the output file and such, whenever you're doing that, and if you have this toggle to on, well, then all of these layers, all these color corrections that you've set up in your V-Ray VFB are going to get baked into your image. They're going to get saved out with your image. Okay. Now, if you have this toggle to off, well, then in that situation, if you hit render to picture viewer, okay, the image that you're going to end up saving ultimately is going to look more like this, where all of these layers are basically just ignored. They're not getting saved with the image. Now, this toggle does not apply to whenever you're trying to save your image out directly from the VFB, for example, or whenever you're using the V-Ray output system. In that case, this toggle really doesn't do anything. But if you are saving your images out using the V-Ray output system or using the save functionality right here, right? Well, then do make sure that you go through all of your layers and just make sure that if you have a layer like the lookup table layer, for example, make sure that this save in image toggle here inside the specific layer that you're working with is toggled to on. Okay, there's a couple of different layers that have this toggle, like for example, the color, the lookup table layer, or the background layer as well. Okay, so whenever you're saving out your images using the V-Ray output system or directly from the VFB, make sure that this is toggled to on. Otherwise, the saved image is basically not going to have this layers effect sort of baked in. Okay, it's basically, if you have this toggle to off, and if you were to now save your image, it would basically save the image without the lookup table. Okay, and in case you're using display corrections here as well, so for example, like you've loaded in an OCIO file, as you can see, this one also has a save in image toggle that might be important to you if you're trying to save these corrections directly into the image. All right, so next up, let's talk about the different GI types, global illumination types that there are in V-Ray. So the default option is the light cache option, and this is really the default that you should be using in most situations because it can do a ton of light bounces. So you're going to get a very nice light distribution in your scene going on if you go with this option. Although that said, if we're being technical, those light bounces are going to be slightly less accurate than they would be if you go with the brute force GI type. Now, the brute force GI type kind of can only do a limited amount of bounces before it starts to get really slow, but it is technically the most accurate solution. Now, which one of these two solutions is going to be the preferred solution for you in most situations? Well, it's going to be light cache. That's why it's the default option. And even though it's technically slightly less accurate than the brute force GI type, you're going to be really hard pressed to spot any differences. And the light cache GI type is just going to render those rays much more efficiently. All right. So TLDR, go with light cache in most situations. Now, if you're an old school V-Ray user, you might be wondering, well, hey, where is my irradiance cache GI type? Well, that GI type is outdated and light cache just surpasses it in pretty much all of the situations possible. So that's why if you're missing irradiance cache, just go with light cache. It's just that much better, really. Okay, all right. Now, there's another parameter here that we should talk about, and this one resides under the interactive menu in your V-Ray render settings. And it's this enable light cache in interactive toggle. And if you toggle this to on, well, then you're basically enabling light cache for your interactive renderer. Okay, if you have this disabled, then you're using the brute force GI type whenever you're starting up the interactive renderer. Now, with the light cache being enabled in your interactive renderer, you will get that light cache pre-calculation happening. So the experience is going to be a little less interactive because V-Ray will need to calculate the light cache for that second or two at the beginning of, well, every refresh basically. But on the flip side, the renderer is going to match your final render settings if you're using light cache in those, okay? And, you know, also you're going to get all the pros of light cache that we just talked about a minute ago. Okay, so we're almost at the tail end of this video, of this tutorial. And one thing that we would still like to mention here is the render settings that we've used for our particular scene that we have in front of us here. And the render settings, as you can see, are pretty basic. So we just went with the bucket sampler type, and then we went with a, I guess, relatively low noise threshold. And that's pretty much all that there is to it. Those are the settings that we've used. We've hit render, and we've ended up with our final high resolution images. Okay, now obviously we did some test renders before that to determine the optimal noise threshold and so on and so forth. And also don't forget, these are the settings that worked for us in this particular scene. You might go with slightly different render settings, but you know, just so you have a bit of an idea of what kind of render settings we've used here. Okay, now before we hit stop on this video, there's still just one more topic that we're gonna open up here, and that is something that you've asked for quite a bit in the comments, and so we've heard you. How do you render animations with V-Ray? What are the render settings that you use? And now you've seen us render out animations of this interior that, you know, we were working in this series here. You've seen us render out some intro animations, and the render settings that we've used were these. Okay, so as you can see, we've got the bucket sampler type, and we've got a little bit of a higher noise threshold setup compared to what we used for our still images. And that's really all that there is to it. As a beginner, you really shouldn't worry about anything else when you're rendering out animations such as these ones. Okay, now, why did we use a bit of a higher noise threshold? Well, with animations, you can kind of get away with a little bit more noise in your images in those individual frames. Okay, so that's why we upped the noise threshold, just so we don't have to wait quite as long to render out the entire animation. All right, and that's a wrap for this one. Thank you so much for tuning in. We hope you've learned something new here. And if you have any constructive criticism or any praise or any suggestions for future topics that we should tackle with these tutorials, please do let us know in the comments below this video. And until next time, take care of yourselves, people.